Hello guys, welcome to this class. We have started our class, our discussion on AC circuit, right? So we've done the introduction, and for this particular class we are going further to discuss resistance in an AC circuit. We also look at capacitance in an AC circuit and then inductance in an AC circuit. Okay, so please get your writing materials ready and then so that you can follow through. Alright, so this is Normal Science Talks Online. You are welcome to our class for today. Please, if you have not subscribed to our channel, please click on the subscribe button, click on the notification bell so that whenever we upload a new video, YouTube will notify you, right? You can reach us through the WhatsApp number showing on your screen. Give us a like, give us a thumbs up, give us positive comments while we continue to dish out quality lectures for you to enjoy. Invite your friends to come and enjoy our class with you. Right, so this is Otobo Michael and I remain your online tutor. So if you have your writing materials ready, please let's just go straight to the class for today. So we're starting with resistance in an AC circuits. Okay, so in a previous class I showed you what an AC circuit is, and I also showed you the diagram like this, and so this is a resistor in an AC circuit. Okay, so this is the waveform. I've shown you this before. So this is the waveform for an AC circuit. All right, so this gives you the circuit diagram for this particular purpose. So this above is a simple AC circuit. Now for this particular circuit, at any instant the current through the resistor I is I, and then the voltage through it is V. So for an AC circuit where you have a resistor connected in series with the current and the voltage that is flowing through the resistor, they are in phase. So what that simply means is that the current and the voltage, they attain maximum and minimum value at the same time. Okay, so just like as you have here. All right, so these two, they are in phase. The instantaneous current and the voltage, they are given by those wave equation that we discussed before now. Okay, so this is the equation for the instantaneous current, and then this is the equation for the instantaneous voltage. Now if you have not viewed the video on simple AC circuit, you have to view that one first before you come to this particular video, because this lecture on AC circuit is in stages. So you have to start with that one, then follow with this particular one, so that you know how these equations came about. Alright, so this is instantaneous current, and then this is instantaneous voltage, and I'm sure you understand this too already if you have viewed that video. Now from Ohm's law, the equation for Ohm's law is this: potential difference of voltage equals to current times resistance. Alright, so current is equals to what? It is voltage all over resistance. So I'm sure you can relate with these two equations very easily. So current is equals to voltage all over resistance. Now if we bring this wave equation into this particular equation that we have, if we bring this wave equation into this equation, we're going to have this, right? This is what we're going to have, and this is what we'll have. Okay, so we're going to have this, and VO from this particular equation, VO all over R is equals to IO. Don't forget that IO and VO, they are peak values of the currents and voltage. So if you have this, it means that you can substitute this into this particular equation. And when you substitute this into this equation, you are going to have this. So this is what you are going to have. Okay, because we have said that I is equals to this, is equals to this. Right, we have said that I is equals to this over this, and which is equals to this. Now we've said that VO over R is equals to IO. So when you substitute that into this equation, into this, you are going to have I is equals to IO sine WT, right? So now we have those two values. So if we bring this equation back now, you know this equation we can write it like that: resistance, right? The resistance now, because we are looking for the resistance in an AC circuit. So the resistance for an AC circuit is given by voltage over I, and this V, we have seen that V is equals to this and I is equals to this. So we can write this equation like this, then these two we cancel out so that we'll have this. So remember that from our previous lecture, we said that the peak value of current is equals to square root 2 multiplied by what? The root mean square value of the current. So you remember that? Okay. Same thing for voltage. The peak value of voltage is equals to root 2 times the root mean square value of the voltage. So I hope you can remember this. So if you remember this, we can actually substitute these two into this particular equation. So if we do that, we have that resistance is equals to VO over IO is equals to this over this. So this will cancel out. So what we'll have left will be root mean square value of voltage all over root mean square value of current. So resistance is equal to, so from this particular equation is that resistance in an AC circuit is equals to root mean square value of voltage all over what? Root mean square value of current. Also, root mean square value of current is equals to V all over R. Also, this. So, depending on what you are looking for, you can actually, depending on the variable, you can use the variable you are looking for as the subject of your formula, and then you solve your problems. Okay, so this is the resistance of a resistor in an AC circuit. Okay, so this equation is for resistance of resistor in an AC circuit. Alright, so I hope this is clear. Alright, so let's just solve one problem. Let's solve one particular problem now. A voltage supply of 12 volt root mean square and frequency 90 Hz is connected to a 4 ohms resistor. Calculate the peak value of the current. Okay, so in this particular question, you are given this to be equals to 12 volts. You are asked to find this. Alright, then you are also giving resistance to be equals to 4 ohm. So if you look at this, you know that this is what you are looking for, isn't it? Okay, so you should look at which equation will relate this and this. From what we have discussed so far, you see that we'll first of all find the root mean square value of the current. root mean square value of current is equals to root mean square value of voltage all over resistance. So that gives us 12 all over 4. I want to let you know all these equations you are seeing, they are easy to apply. Statistic. So the root mean square value of the current will be equals to 3 amp. Okay, it will be 3 amp. So from here now you can now find the peak value of the current. Remember that root mean square value of current is equals to what? It's equals to the peak value of the current all over square root 2. So we just discussed that now peak value of current is equals to root 2 multiplied by the root mean square value. Okay, so we can just substitute into this. So square root 2 times 3. Okay, so if you solve this one out, you are going to have the peak value of the current to be equals to 4.2 amp. Alright, so this is how to apply this equation that we just if you were to find the resistance, just for you to make the resistance the subject of the formula. Okay, so this is how to apply this equation to solve problems. I hope this is clear. So now we want to look at capacitance in an AC circuit. Okay, so this is an AC circuit. In the former one, we discussed resistance in an AC circuit. So this is a capacitance. This is about a capacitor in an AC circuit. So for this particular setting, when an AC voltage is connected in series with a capacitor of capacitance C, just like this, the voltage and the current are out of phase, so they are not moving together. That is, they are not in step. The current is said to lead the voltage by 90 degrees or pi over 2 in radians, while the voltage is said to lag on the current by 90 degrees too. So the phase angle between the current and the voltage is this 90 degrees that is here. Now remember that the capacitance of a capacitor is the ratio of the maximum charge to the applied voltage, and this is it. Ratio of the charge to voltage is the capacitance of a capacitor. So if you have not viewed my video or the class on capacitance, connection of capacitors, you can go and view that video. Now the capacitive reactance, the reactance of a capacitor in an AC circuit, is the opposition to the flow of AC offered by the capacitor, and this is represented by X. It's represented by this. Okay, this is represented by that particular value, or by that symbol, not value, symbol. Now from Ohm's law, just as we did in the previous this thing, from Ohm's law we have that voltage is equals to current times resistance. Now what you will do in this particular case is that in the place of where you have your resistance, you will replace it with this capacitive reactance XC. Right, so the equation will now look like this. This is the voltage of the capacitor multiply voltage of the capacitor is equals to current times the capacitive reactance of the capacitor. We have said that the reactance of the capacitor is equal to the opposition to the flow of current that is offered by the capacitor. So the voltage of the capacitor is equal to, or the voltage across the capacitor is equal to the current multiplied by the capacitive reactance of the capacitor. Okay, so where you have your resistance or your resistance, you put the capacitive reactance. So your equations will now look like this. Okay, so it has been deduced that the capacitive reactance of the capacitor is equals to the root mean square value of the voltage all over the root mean square value of the current, and this is equals to 1 all over the phase angle multiplied by the capacitance. And you know that angular velocity is equals to 2 pi f multiplied by capacitance. So capital C is the capacitance, the F is the frequency of the current, and then so this is the equation that is very key for the reactance of a capacitor, or the capacitive reactance of a capacitor. So here you have that the reactance is equals to 1 all over 2 pi irradiance F times the capacitance. So as we said, if you see the voltage and the current, they are not in phase. It's like they are moving opposite to one another, and one is leading and one is lagging. All right, so this is what we have. The capacitive reactance equals to this. So from here you can actually find the capacitance of the capacitor. So the capacitance of the capacitor is equals to this. It's equals to 1 all over all the reciprocal of 2 pi f multiplied by the capacitive reactance. Okay, so this capacitive reactance, this capacitance of the capacitor in farad, and there is frequency in hertz. Right, so the equation that is very key for you is this equation 1 and this equation 2. So take note of this equation when you are solving any problem that has to do with capacitance in an AC circuit. Alright, so we have discussed a lot on this, and don't forget also that the root mean square current for a capacitor in an AC circuit, the root mean square current is equal to the root mean square voltage all over what? The capacitive reactance. This is gotten from this part, just to make this one the subject, right? So this equation is gotten from this particular one. So it's not like I'm bringing a new equation, just look at it. And this one now is gotten from this. So nothing is new. I only made the current the subject of the formula, and I brought this out so that, because sometimes you start to look for some equations that are already there, that's looking at you, right? Okay, so let's solve some problems so that we can also have better understanding of this equation. So this question says that a 2 microfarad capacitor is connected directly across a 150 volt root mean square voltage, right? That has a 60 hertz as frequency in an AC source. Find the root mean square value of the current. Okay, then find the peak value of the current. So you are giving here the capacitance of the capacitor. So you are giving C here to be equals to 2 microfarad. And you know that 2 microfarad is equals to 2 times 10 raised to power minus 6 farad. Okay, so you must do that conversion. It's 2 times 10 raised to power minus 6 farad. Then you are giving frequency to be equals to 60 Hz. You are giving voltage to be equals to 150 volts. Now this voltage is your root mean square voltage, right? Root mean square voltage is given to you to 150 volts. So from this particular question, what you are going to look for first, because you are asked to find the root mean square value of the current, you are already giving root mean value of voltage. So from these equations, you have that the capacitive reactance of this capacitor is equals 1 all over 2 pi fc. Okay, and we also have that root mean square current is equals to root mean square voltage all over this. So these are the equations that you are going to use to solve this problem. So starting with the first one now, we are going to first of all find the capacitive reactance of this particular capacitor. So substitute to this particular equation, you have 1 all over 2 times 10, 2 times, okay, so let's start with that 2 multiplied by pi. You have 2 multiplied by pi multiplied by 60 multiplied by 2 times 10 raised to power minus 6. Okay, so that's what we have. So when you multiply, if you solve everything out using your calculator, solve everything out, you have that xc, which is the capacitive reactance, is equals to, don't forget that the unit of this capacitive reactance is equals to the ohm. Okay, so you have 1324.4 ohm as your capacitive reactance. So once you have gotten this, you substitute into this equation to get your root mean square value. So the root mean square value, you have been given the voltage, root mean square voltage to be 150 all over this. So that gives us 1324.4. By the time you work this out, you are going to have 0.113 amp. Press that out from your calculator. So this is your root mean square value of your current. So having gotten this, it is now easy for you to find your peak value. Okay, so peak value of current is equals to IO, which is equals to square root 2 times root mean square value of your current. Remember that? So that gives you square root 2 multiplied by 0.113. Okay, so by the time you work this out, you are going to have 0.16 amp. That will give you your root mean square value. So you can see how all these equations, they are related, and we are able to bring all of them together to solve this problem. I hope we are okay with this. This is also another question. This is a JAM question. So for this particular question, you are asked to find the frequency, it's not known, at when a capacitor or capacitor, this we have a reactance of 250 ohms. So this you convert to farad, okay, by multiplying it by 6, by 10 to the power minus 6. Then you are giving the reactance to be equals to 250 ohm. So let's look at the what you will be giving. So what we are looking for now is the frequency, is it not? So we know that from this particular equation, reactance is equals to 1 all over 2 pi f capacitance. So there you are looking for f, so make f the subject. It will be 1 all over 2 times pi times capacitance times reactance. Is that okay? So what you do next to substitute into this equation. So you are going to have 1 all over 2 times pi multiplied by capacitance, which is 2.5 times 10 raised to the power minus 6, multiplied by your by the reactance, which is equals to 250. Alright guys, so by the time you work this out, you have your value. Press your calculator. So if you press your calculator and you work this out, you will have 800 all over pi. So you can decide to find the value of pi and get the whole number value. So this is what you have, or you can find the value of pi and divide it out, but this is what you will have. Remember that do I have to give you that hint now? Okay, so normally in mathematics, this equation you can write it as this, you can write it as this, your simple indices all over 2 times pi times 2.5 times 250. Okay, so you can actually do this. So by the time you work this out, you are going to see that your answer will be, you have something like this, so that you don't have, this is what I've converted using indices law to get this. Alright, so there's nothing to be confused about when it comes to that. Okay. Alright, so finally we are looking at the inductance in an AC circuit. So sorry about that. So this is a sign for an inductor. So an inductor opposes the change in the current, and as a result there's a delay. Okay, there's a delay in the current, right? So in this particular case, the current lags behind the voltage by this angle of 90 degrees, and the phase angle between the current and the voltage is equal to 90 degrees, right? So this should be this equation for, remember the equation for voltage. Okay, so for this particular case, since the current is lagging behind the voltage, this will be the equation for the current. Now, inductive reactance, the reactance of this inductor is the opposition to the flow of AC current offered by this inductor, and that reactance of the inductor is also called impedance. So in case you are asked to find the impedance, you know that you are looking for inductive reactance. Okay, So if you are asked to find the impedance of an inductor, it means you are looking for what? Inductive reactance, and it's represented by this. So just like as we did for capacitive reactance, essentially that you will do. Okay, so this is Ohm's law, and this is what we did for capacitive reactance, same thing and all that. So the voltage across the inductor is equals to this. Remember this equation where you have XC, then your inductive reactance, which is this, is equals to this over this. Remember that, and you also remember this. Okay, you remember this and this, so this gives us this. Okay, so for inductive reactance is given to you as 2 pi f L, where L is the inductance of the inductor, F is frequency, and XL is the inductive reactance. Okay, so we have these two equations now, right? So now you can actually, from this particular equation, you can actually find the current of the inductor. Or you can, okay, this is already the current, so you can actually find the inductance of the inductor. Okay, so if you bring this equation here, okay, so you can have that XL is equals to VL over L. All right, so XL is equals to 2 VL. SL is equals to 2 pi FL, which is VL all over the current through the inductor. Alright, so we are looking for the inductance, which is L. So make L the subject of this so that you have VL all over 2 pi F multiplied by the current. So with this equation, you can find the inductance of the inductor. So this is what we have here. These are the same thing. Okay, these are the same thing. Alright, so this is the equation for the inductance of an inductor. Then this is the equation for the inductive reactance of an inductor. This is the equation for the inductive reactance of an inductor. Then just like for the other one, we can also write that the root mean square current, of an inductor is given to us as what? Root mean square voltage all over what? Inductive inductive reactance. Okay, so please take note of all these equations that are given to you. As I said before, this equation is the same, is gotten from this part. It's got it from here, right? It's got it from here, so it's not a new equation. It's just for me to make the root mean square current the subject of this formula. That is what gave me this particular one. So I didn't do anything new. Alright, so take note of this equation so that we can use them to solve some problems. Okay guys, so let's solve some problems and see how far you have understood this. So this is a question for us to solve, and so this question says that find the impedance. Impedance, as I said before, is the inductive reactance. So it says find the impedance across an inductor of 0.2 Henry. The unit of an inductor or the unit of the value of inductor is Henry. So across an inductor of 0.2 Henry inductance, when an AC voltage of 60 Hz is applied across it. Fine. Now, if the voltage is given by this equation, calculate the root mean square and the peak values of the currents. So the root mean square and the peak value of the current. This is a wire question. Okay, so here you are giving the inductor value, or the inductance of the inductor L is given to you to be 0.2 Henry. 0.2 Henry. Then you are giving the frequency of the AC voltage to be 60 Hz. Then you are giving the wave equation for the voltage to be 150 sine 120 pi t. Okay, so these are what are being given to you in this particular question. So for us to go ahead, you have to find, you will say we should find the impedance, which is the inductive reactance. Impedance or inductive reactance is given to us to be equals to 2 pi FL. Okay, so already we have the values for F and S, so let's substitute this. So you have 2 multiplied by pi multiplied by 60 multiplied by 0.2. So if you work this out, you are going to have that X, which is impedance or inductive reactance, equals to 75.40 ohm. This is your impedance or inductive reactance. Okay, so now that is the first part of this question. Now they say that if the voltage is given by this equation, calculate the root mean square and the peak values of the currents. So you have been given this equation now. Alright, so from this particular equation, if we compare it with the equation for with the wave equation for voltage, we have that V is equals to VO sine 2 pi FT. So once we know this, we'll know that from this equation, and VO is equals to what? The peak value of the voltage is equals to what? Is equals to 150. So peak value of voltage is equals to 150. Alright, so when we compare these two, this is what we'll have. Now from here, we can find the root mean square value of the voltage. So root mean square value of voltage is equals to root mean square value of voltage is equals to 0.71 multiplied by VO. So if we substitute into this equation, we're going to have 0.71 multiplied by 150. So multiply that out with your calculator, you are going to have 105 volts as your root mean square value of your voltage. Now from here, From this equation, root mean square value of current is equals to root mean square value of voltage all over the inductive reactance. Is that not? So if we substitute into this value, we'll have that 105 all over inductive reactance all over 75.4. So if you work this out, you have that the root mean square value of the current is 1.39 amp. I hope you are following. So this gives us 1.39 amp. So from here you can now find your the peak value of your current. You can find the peak value of your current. So your peak value of your current, we remember that the peak value, remember that this inductive reactance is equals to peak value of voltage all over peak value of current. So peak value of your current is equals to peak value of voltage all over inductive reactance. So you have that peak value of voltage is equals to 150. Then your inductive reactance is equals to 75.4. All right. So that will give you your p value of your current to be equals to 1.99 amp. 1.99 amp. So this is your p value of your current. So that is just the solution to this problem. So you can see how we brought all the equations to bear. All of them, we brought them out to bear, right? So this is another question too. A 220 volt 60 Hz AC supply is connected to an inductor of 3.5 Henry. What is the current passing through the inductor? You are given pi to be 22/7. Okay, so here you are asked to find the current that is passing through the inductor. All right. So remember that we said that from one of our equations. Okay, so here you are given in voltage to be 220. Let's just bring those ones out first. You are given frequency to be 60 Hz. Then you are given the inductance of the inductor to be 3.5 Henry. So here now you are asked to find current. See not? You are asked to find current. Okay, so remember that we said that inductance is equals to voltage all over what? 2 pi f current. Alright, so in this particular question, you will now make your current the subject of the formula, because that's what you are looking for. So you have 2 pi f times L, which is the inductance. So just substitute into this equation. So you have 220 all over 2 multiplied by 22/7, that is given to you, times frequency, which is 60, times 3.5, which is the inductance. So press your calculator and you will have 0.167 amp as your current. So quite easy, right? It's quite easy based on your understanding of the question. Okay, so we have covered a lot and we solved a lot of problems on this. So this is your test, your understanding. Okay, so this is your test, your understanding page. Please solve these questions and then, yeah, just so the, remember this one, you have to find the what? The combined capacitance of these capacitors, right? Once you know the combined capacitance, this is the frequency of this particular system. Then you have the combined capacitance. What will be the reactance? Hmm? What will be the reactance? So you should be able to solve this. Then calculate the amount of heat generated and external load or resistance 0 ohm if an AC or peak value 5 amps pass through it for 100 seconds. Okay, so you have this. So what you are going to look for first here is to find the root mean square value of the current, because that is the current that is flowing through the system. That is a direct current. So you find that one and then use that one to find the heat generated in the system. So I've given you the example for that. At what frequency would a 10 ohm inductor have a reactance of this? Okay, so we'll solve something like this. Okay, so you have the reactance, you have this, so you can find this frequency. Simple and quite easily done, right? So thanks a lot for your time. Okay guys, so this is where we're ending this class. Thank you so much for your time. If you have not subscribed to our channel, please subscribe. Click on the notification bell so that whenever we upload a new video, YouTube will notify you. This is Normal Science Tutors Online, and you can reach us via the WhatsApp number that is showing right on your screen. Please invite your friends. Help us to cascade this information that you have a lecture class that is going on YouTube, right? So thank you so much and we appreciate you for your time. Thanks and see you in our next class.